Morning, everyone. Thank you again for attending. My name Johan Stale. On the left-hand side on your slide. Um, been with Spirex for 13 years. Um, our presenter, Francisco, from the EMEA division, our steam quality specialist and business development. He's been working around the world, looking after customer steam systems and doing audits and assisting them to a better future in their steam system. Then Debbie Robinson, she's our marketing manager and also personal assistant to our MD that put this whole thing together for us today. And I hand you over to Francisco, which will present to you today. Thank you very much.
Thank you, Johan. Thank you, Debbie, for the lovely introduction. What I'll do is start off if the slides seem to work. I don't know what's happening there.
All right.
Okay. Let's start off straight away. Normally, when people talk about steam quality, the first thing that people comes to mind is really on the process side. But when we talk about steam quality, we must understand that this is actually a bigger picture that we need to take note of. Now, there's two major concepts or two major issues that we need to actually take in consideration when we actually thinking about steam quality. The non-condensables, slides again, in the non-condensables and the actual wet on the steam. Now, how important is this to you? It's actually very, very important. I've actually put some factors on here so that you can actually read for yourself, obviously, to understand how this actually affects the actual plant side, whether it's secondary or actually direct in contact with your process. Now, the presentation that we are going to do today mainly focus on the actual steam quality when it's in direct contact with the process, either through sterilization or directly into the process. But we must not forget that a lot of people compromise on the actual installation, and they look at cost versus the actual quality of the steam on the process side as well as on the plant side. What we must understand that if we do not get the mechanical correctness of the steam up, to your actual piece of equipment, it can actually affect the actual equipment in itself. I mean, the life cycle of the equipment and various other things that can actually affect, like, heat transfer. If you don't have the right heat, right steam, normally they have a benchmark around 95% dryness of steam wherever the process is. And that's obviously sometimes difficult to achieve if you do not have the right mechanical correctness of that steam. Now, if you are interested, obviously we can assist you in that to make sure that not just for the quality side of the actual steam, but also the safety of the steam as well, which you need to take in consideration for both factors when we talk about steam quality. Now, I always want to start off with the stream triangle, and this is a fantastic triangle to actually indicate and represent and educate people out there the actual various grades of steam that there are within a process, within an industry out there. Now, there are different ways of doing things nowadays, and obviously we have to work and we have to keep up front with new technologies and to make sure that we actually eliminate or even try to minimize some of the risks happening in the actual process. Now, we get a lot of concerns, a lot of people coming to us and ask us, we have issues with our process, we have issues with the steam, how can you help us? And this is where this presentation today is hopefully is going to help you understand more when we talk about steam directly in contact with a process. Now, we'll talk about the triangle. Now, I'm going to mention and I'm going to focus on the various types of steam in industry. Now, we must understand that when we talk about clean steam, that is not filtered steam. A lot of people interpret filtered steam as clean steam. What filtered steam is, or culinary steam, or whatever steam that you may want to call it, it's actually just a filter in front of your process to minimize some of the actual particulates that are going into your process. That does not take the water residue or the chemical carryover that happens within the boiler that I'll talk later on the slides. So let's take note what that actually is. I'll show you basically what a filter is. Right, that is a filter, and normally an FDA guidance, there's a guidance that actually gives us some direction in actually to try to minimize some of the actual contamination that can occur within the actual process. Now, in industry nowadays, we are in the last couple of years, or even more months, we actually have had a lot of complaints about processes where they have a taint and odor and smell that actually are affecting the actual process. Now, we understand where that's coming from. Obviously, when you're using a plant steam, it carries various variables, a lot of uncontrolled measures that you cannot actually control, or you can actually minimize, but you cannot control it fully unless you obviously go to a safer process, which is obviously clean steam, and we'll talk about that later. Now, so FDA says if you are operating or using steam directly into the process, either for sterilization or directly, it is recommended that you use a minimum requirement of a 5-micron filter as close as possible to the point of use, and thereafter in stainless steel. Now, as was said to you, this is not clean steam. This is actually filtered steam. It actually just takes the particulates from the system to make sure that it doesn't land in your area. Now, I always like to use this little diagram here to just explain that a 5-micron as this is more an indication type of thing. So if you look at the graph in front of you at the moment, there's what we call a red line there. That red line is actually indicating a 5-micron filter. Now, if we look everything on the right, the 5-micron seems to prevent that from going through. If you look everything on the left, it's actually all the things that actually pass a 5-micron filter. So this is just a good indication to show you that a 5-micron filter is only as good as a 5-micron. Now, as I said to you before, we're obviously getting a lot of carryover, inconsistent carryover that comes from a boiler, and I'll explain that later on as well. And those carryover and chemicals that are coming through from the actual plant steam, a filter will not stop that from going through. That will still go through into your process. Again, the filter will not stop any smells or odors that are actually transparent within the actual plant steam. That won't stop that as well, again. So the only way that can actually be eliminated is actually clean steam. We'll talk about priming and carryover. This is actually very important within understanding what happens within the boiler house. Now, what is this? Well, what happens is your boiler has to react to the sudden demand of your process conditions. So let's use, for example, if we are our process requires 1,000 kilograms an hour at 3 bar, then the actual boiler has to operate and has to give you that 1,000 kilograms at that pressure. If you don't get those that condition, then you're going to starve the actual process. So that what happens is that sudden demand, you get carryover, you get excess chemicals that comes from the actual boiler house, and that gets carried over into your distribution system, and that eventually ends up into your product. Not only that as well, the actual steam and the water tends to absorb the actual steel, metals, or whatever the actual piping actually made, and that actually has that smell and that taste that actually leaves into your process at times. So can we actually eliminate carryover? Well, we can actually minimize it. We can actually minimize it by putting some controls into place. Now, normally when we do a HACCP and we understand the actual process, we try to minimize all the opportunities to or on the controls measures of an existing plant steam. So then we recommend a couple of operating procedures that we put in place to try to minimize some of that carryover. It cannot be eliminated totally because it'll always happen, it'll always occur depending on the boiler demands and all that. So it'll always be there, but it will be minimized. So we can put some controls to try and assist the plants out there to make sure that you don't get excessive carryover going through. I like to always use this example and explain how and where the contamination can occur within the process. And that's quite simple. It can happen from the CIP. It can happen from the steam system because we know that the condensate is always returned. In most cases, it's returned. So whatever it carries or whatever it picks up within the condensate pipeline, it goes back to the feed tank. From the feed tank, it generates boiler. From the boiler, it generates the plant steam. Now, we all know, and it's quite easy to understand, we don't have to be a professor to know these. If the water in your hot well or in your actually feed tank is actually contaminated, then surely the steam is going to be contaminated. The most important ingredient out of the whole boiler process, sadly, is the actual water. So it's very important that you manage that. So whatever it's carried or whatever the CIP or whatever the actual condensate or whatever's coming back to the feed tank has contaminants, that's going to reappear when you're producing steam. Now, we must understand, and we'd like to, people are very conscious about steam. They say, well, steam, we are happy with steam because it is at high temperature, it kills all the bacteria. That's quite right. It does do that. But as I said to you in the beginning as well, we need to control the actual wetness of the steam, because if we don't get the right steam dryness, then that could also affect the actual process side. So there's two things that we need to look at. We know the biological contamination steam does kill. We understand that. But the volatiles is the one that we need to actually administrate, or we need to manage, or we need to eliminate. Now, that's very difficult to do that within a plant steam. So if we'll talk about HACCPs later and how that actually is managed around the steam principles of HACCP. Now, in order to eliminate those volatiles, such as chemical carryover substance that are happening within a normal plant steam, well, the only way to do that is actually clean steam. Why? Because there aren't any chemicals. I explain that later, the operation on how you generate clean steam. So as part of HACCP, you will see, if you do your HACCP principles properly and you take steam as part of an ingredient that we will talk about that later, it definitely guides you in the direction of a clean steam, because that's where all the actual contaminants are eliminated. Now, I always like to talk about this one in particular. A lot of food and beverages, a lot of breweries and a lot of industries such as that, they use what we call activated carbon filters. Now, activated carbon filters are there normally to pass the water through for the process side, and the water gets used because they remove the chlorines, the taste and the odor, which get used for the process. Now, we have, I believe there's two types of contaminants, or actually bacteria, that actually grow in carbon filters. And it's been discovered that the only way to get rid of those two bacteria is sadly steam sterilization. So a lot of people has converted the actually activated carbon filters into steam steriles to actually make sure that you apply steam at a low pressure, and then once that beads are all actually sterilized, then you know you're safe, that bacteria cannot grow in there. Now, a common practice of cleaning an activated carbon filter is normally through treated water, backwashing treated water. But it's proved over the years that there is some bacteria that the treated water method doesn't take away those two bacteria, particularly in high temperatures, obviously. And so it's important to know that if you have this issue or you haven't got steam sterilization, it's something that's worthwhile looking at. Right. When we talk about cross-contamination, I just use this example. If you see there's a plate heat exchanger, and on this plate heat exchanger is showing a little pinhole. A little pinhole that's actually appeared in the system for whatever reason, but that pinhole all of a sudden allowing the actual condensate to be contaminated, the condensate line to contaminated. In this particular case, it was running back to the actual feed tank, and obviously the feed tank was being contaminated, and they didn't know where it was coming from. So there are systems that we can put into place to try to detect that and to make sure that we release that contamination so it doesn't actually go back to the actual feed tank. And I'll show you of some systems. I would like to use this diagram at the moment to explain, if it comes up, here we are, like to explain, to show you how the actual process and where the actual contamination appears within a steam systems. Now, as I said to you, that the most important ingredient out of a steam systems, is the raw water. So if your raw water tank or your feed tank is actually contaminated, then logically the steam is going to produce whatever that water quality is going to be. So therefore, it could be contaminated. So if it could be contaminated, that means there is a risk. So therefore, we need to manage that risk. And I'll show you later in terms of HACCP what the risks are and how to manage it and how difficult it is to manage it. But for this particular example, if you can see on the diagram where it says number 5, just after number 5, there is what we call a filtered steam or culinary steam, is what lots of food and beverage industries tend to use as a minimum protection. Now, what I did in this particular case, and I'll show you some other samples as well, I've taken a sample of condensed the sample of the steam from the downstream of the actual filter to show you or to demonstrate to industries out there how safe and a 5-micron filter actually is. Now, when I did the sample, I took it in from the bottom of the actual pipeline because I know that if there are any particulates rising within the actual steam line, it'll be on the bottom. So I did take it and I managed to find an area on the bottom to take the actual sample. Let me show you how that actually looked. So there's a slight delay. Right. This is the sample that I've taken. Now, I use 3 samples to prove to the industries out there that by taking the 3 samples here, one of them is actually raw water from a tap. The other one is actually from a condensed sample from a clean steam generator. And the other is actually the sample I've taken after the 5 micron. Now, looking at the samples as you see there currently, it is hard, it's very difficult to tell which of those are coming from those sectors. Now, for the slide that I'm going to show you now, I've taken the bottle and I've shaken the bottles to show you where the actual contaminations occur. Now, if you look at the next slide, this is now taken the bottle, I've shook it to actually show you that there are fine particulates coming through into your area. Now, if you look at the sample on the left, it is very fine. That is less than 5 microns. So that's actually passing a 5 micron filter. But that's not because if you are doing absorbing a big amount of product, you may not see those little specks or the brown coloring into your actual product. What the concern mainly is now that we are, particularly in dairies and cheese making, we have noticed as well in brewing when they're doing sterilization of beer barrels or whatever sterilization they do, we've noticed that they are having taste and smell that it's affecting the process. Now, they weren't worried, or they weren't understanding where the smell and this taste were coming from. And obviously, it is coming from the actual plant steam, which a filter cannot eliminate that from happening. So therefore, if you want to make sure that you don't have those tastes or those odors or those smells that are appearing into your process side, sadly, the only way to go is actually clean steam, which is the one in the middle, and that is clean steam. And I'll show you how to generate clean steam. Now I'm going to show you some samples that I've also taken from various types of industries to show you that further contaminations can occur. This particular sample I took a very well-known process manufacturer where they were operating like this. I think it's around 30 or 40 years they were operating. And this sample in particular was taken without any protection. In other words, they were running for 35 years with no protection at all, until obviously I did an audit there and I pointed out the issues and the risks in relations to HACCP. The quality manager changed the attitude, turned away, and then he converted to clean steam because he was really concerned about that happening in his process. The other sample I'm going to show you here, just a little video to explain to you. A normal plant steam has a lot of crevices and a lot of dead legs. We know that, we acknowledge that. And that's why when we design a clean steam system, we eliminate those dead legs and those crevices. But then again, the actual dead legs, there's no contamination that can appear in clean steam. But let me show you this video and hopefully it works. Let me go back. Sorry about that. There we are. I'll show you a quick video. And this was taken just before entering the actual process. Now, if you look at that, that was one of the dead legs, one of the areas that was actually been accumulating in the actual steam line. And that can break loose at any time when that can come through. Now, we know that, and we need to acknowledge that steam does change every second. So therefore, the only way that any supplier can give you the consistency or the actual guarantees that your steam is actually at the same quality every second, sadly, is clean steam. Nobody else can give you any other guarantee other than using clean steam for your process. Now, where does these contaminations occur? Well, it can happen from various stages of the process. It can happen where the feed tank, where the chemicals adding, it can happen the boiler scale, corrosion, particulates. You can have cross-contamination appearing, obviously from stuff going back into the feed tank. One interesting thing that I always like to talk about is, particularly in the boiler house, if somebody, let's say your boiler chemicals or the person, the consultant that comes and checks the actual feed tank or the water feed, he checks it once a month and he takes a sample, he analyzes it and he says, oh, I need a little bit more of oxygen scavenger, for example. And what he does is he adjusts the actual dosing pumps from 1 notch to 2 or 3 notches, and that starts pumping a little bit more of oxygen scavenger into the system. And then obviously a month later or 3 weeks later, the guy comes back and he checks the content of the chemical within the process again, and he says, well, you know what, I've added too much, I better turn it back. But in the process, that's all gone through. It's all gone through into your process side. So that managing of that chemicals, that managing, there's too many variables and too many inconsistencies that can occur within the actual chemical dosing system over there. So it makes it difficult to manage. So therefore, if you obviously want to have peace of mind and you want to try to eliminate those risks in respect to chemical carryover, besides obviously the contaminants, sadly, clean steam is the only way to do that. Now, as you heard me saying in the previous slides, if these are some measures and some protection that we can put into place. Normally we put turbidity and CCD systems. Now, what does this do? Well, it actually measures if the condensate is actually contaminated for whatever reason, it'll pick it up on these two systems. Now, it ideally would be to put one in line with the other, just in parallel, so that one measures the one thing and the other measures the other. And then when that gets contaminated, it actually dumps it. It dumps the actual condensate until it's actually corrected, and then it'll allow it to go back to the actual feed tank. So this is one of the actual minimizing some of the risk that you can put into place. If we talk about guidelines, a lot of people say, well, which guidelines do we use? What is telling us this is no this, is no that? Well, let me tell you something. There are lots of guidance. It's us to choose what we actually choose. Ultimately, there's two guidances that I like to do, or one in particular that I'd like to mention to yourselves is around HACCP. Whether we choose to do the others or not, it's our own choice or the individual's choice or the company's choice. But normally they would not take the risk. So if there is a legislation that actually can help with actually preventing from obviously contaminating the food, so that will be introduced into your process. But the one that we need to take in consideration and we need to actually manage, which people don't seem to understand in respect to steam, is HACCP. How does that actually work with us? Now, we know, and I've been saying from the beginning, we know that steam, when it isn't direct in contact with the process, it is an ingredient. Why I say that? Because if you take, for example, any of your products, let's take a jar of tomato sauce. There you will always see there, it says the sugars, it says the waters, it says the salts, whatever the process is. Those are the ingredients that has to be disclosed within the actual label of that actual particular product. Now, steam is also an ingredient. So therefore, we should be really start advertising and actually start promoting and putting that into the label as well, because it's adding into the actual process as an ingredient. So it's important to understand that it is an ingredient. How does that apply to you? I'm going to just go to the next slide. So let's have a look at clean steam. This is the most important, and this is the misunderstanding or misinterpreting what is actually clean steam. Now, when we talk about clean steam and we go up on the angle now, in the last 4 or 5 years, a lot of food and beverage industry are understanding the concept of filtered steam and understanding that filtered steam does not give them the peace of mind within their process. They're coming to us and they're asking us as specialists. It says, we know that filtered is not the safe ways to go. What is a safer way to go? And then obviously that is clean steam. And again, now we've worked on a lot of R&D to try to produce these type of equipment solutions to make sure that we eliminate those contaminants occurring within the process. And how do you generate clean steam? Well, it's quite simple. I'll explain it. First of all, you've got an RO water. What is RO water? Well, what we do is we have a borehole water, tap water, or whatever water you want to come through, goes into the two vessels. You see those two cylinders, those are softened water. So they soften the water prior to going to the RO. Then you have what we call a carbon filter, or this is a cartridge carbon filter, and this actually removes the smell, the chlorine, the taste, the odor within the water, and that gets pumped through the reverse osmosis membranes, and that water that is used into the actual generator. That is the only water that gets used into the generator. No other water gets used in the end generator. No chemicals gets added into the generator. No condensate gets returned into the to the actual generator. Why? Because there could be a possible of contamination occurring from the condensate. It may have picked up something without the return lines, so therefore you do not return. It is not recommended to return any condensate, and you do not add any chemicals. So in other words, the steam that's coming from the generator is chemical-free steam. In other words, there's nothing in the actual steam, so there's no reason for it to actually contaminate the process. Then we use what we call plant steam, dirty steam, black steam, whatever steam you want to call it. And that plant steam goes through a stainless steel 316 coil, and that goes through and heats up the water, which is reverse osmosis water. That bubbles up, and you can see it generates clean steam on the actual green arrow that you can see. So that is the steam that goes into your process. That is the steam that you use for sterilization, and that is the only steam. So you use plant steam to generate clean steam. Hopefully, if there is any questions towards the end of the thing, I'll answer them as we're going along. So the generator looks like that. Mainly they are. Now the generator, as I always said, it is an important integral part or solution of creating clean steam. That generator is made in conformance with all the actual hygienic and sanitary conditions that's required to make sure that your system is safe. So the generator is one part of the actual clean steam system, and obviously the water is the other. Now we also mustn't forget about the distribution side of it. The distribution side of the clean steam has to also be designed with using the best practice. Now, as I said to you, remove the actual crevices. Make sure that you remove the condensate so you don't have any wet steam going through. The generator will guarantee 98.9% dry steam at all times. The generator will give you consistent quality of steam every second. So if you want to have peace of mind and you want to make sure that you actually sleep at home safely and make sure that you don't have to worry about your process, the only way to do that is actually clean steam. Now, the clean steam generator does have a blowdown system. It's automatically blow down. So what happens is if it doesn't get used, automatically it replenishes with clean water on a frequent basis to make sure there's always new water in the actual generator. How does HACCP apply? Well, as I said to you from the beginning, we need to understand and we need to acknowledge that whether we like it or not, when steam is used directly in contact with the process, either through sterilization or directly into your process, it is sadly as an ingredient because we're adding whatever the makeup of the water, whatever that carries within the steam is actually going into your process. So therefore, we need to consider as an ingredient. How do we do that in respect to steam? Well, I'm going to show you. This particular legislation is actually quite interesting. If you take the last phrase there, it says steam used directly in contact with food is not to contain any substance that is present or a hazard to health or likely contaminate the food. If you take, for example, those samples that I've taken you, or you acknowledge that a plant steam does have contaminants, we know it does, therefore it actually allows us to apply a HACCP. So we have to do a HACCP analysis to understand where are the risks within the process that we can eliminate to make sure that that does not end up in our process. Well, I said to you in the beginning as well, the most important ingredient out of the whole process, out of the whole steam line is the water. Now, when I go back to a clean steam, I said to you, the important ingredient is water. Now we are managing the water quality going into a certain specification requirements in terms of chemical requirements that you need to, the water needs to comply with to actually qualify to clean steam. So we know that that water is managed and consistent at all times. Therefore, the steam produced from a steam generator, from a clean steam generator, will be always consistent. Whereas in plant steam, if you look at all those variables that you see, all those factors that you see that generate to generate plant steam has a variation. There are variables. They actually change inconsistently change on second by second. So in other words, we have to manage that and we have to apply HACCP to each and every of those factors that you see there on the screen at the moment. And that becomes a manageable, very difficult to manage. And it's hard to manage because you have to keep on assuring that the HACCPs are applied to make sure those risks are not there at any one time. So therefore, to have that peace of mind and to make sure that those inconsistent variables don't change, then obviously the people all the industries go and turn to clean steam because that's not necessary within clean steam. I always like to also use, if you can see on the top right hand side, that what we call a condensate dirt pocket, or let's for example say it's in all steam systems we will have condensate dirt pocket, it's good practice to put them in. It's good mechanical correctness to put them in to make sure that we get the best steam dryness out of your system. Now, these dirt pockets, I'm not even going to talk about the actual crevices that are actually within a plant steam. Just focus on this little dirt pocket. They could be, some of them could be in the roof space. Some of them could be in areas that you can't access through. And now, as part of a HACCP, to make sure that these dirt pockets are cleared or clean at all time, that it doesn't have or break through some of the dirt particulates going through on these conditions, you have to drain them as part of a HACCP control measure. You have to drain them before startup or before whatever. So you have to keep on doing that. And that's become a bit of an administration. So again, had you gone to clean steam, that would not be required because it doesn't, there's no dirt within a clean steam system. So if you take the risk analysis and you look at the way to go for it, a lot of people, you know, that if they know there is a risk associated to the process, there's nobody that I've met today that says no, they can live with the risk. So therefore, they will always ask you how to minimize the risk. Now, if you want to minimize the risk, the only way that you can do that is actually putting filters into place before the point of use. Now, that will minimize the risk. If you are really concerned, and obviously, you know, speaking to quality managers and process engineers, they seem to be take it more seriously in respect to actually steam quality. Then obviously, you know, if you want to eliminate the actual risks, so in your process, not just because of the contaminations point of view, but also the actual smell, taste and odors that a normal plant steam sort of passes through at times, then obviously clean steam is the right way to go. The materials of construction, this is actually very important to understand that if we are using filtered steam, 304 is acceptable. Now, when we are using clean steam, because we know that clean steam is generated with reverse osmosis, we know that reverse osmosis is quite aggressive, so the best and the only route and the best materials to use is a minimum requirement of 316L. Now, the generators that are manufactured by ourselves, they're all manufactured to 316L. Any contact part that is in contact with the steam is manufactured to the 316L compliance, obviously with the other FDA compliances as well. Now, we spoke about steam quality. Now, remember that steam quality applies both on the process and also on your plant. So the benchmark that you need to do for both sides, plant and process, is to try to achieve 95%. Now, there are systems today that can measure your actual steam dryness and also your non-condensable and also superheat. There are systems that can measure that. And those systems we can put into your process lines and understand where your benchmark is. A lot of the companies that I've gone to, they said, well, you know, dryness is very important for my process. I said, well, what is your dryness? And they said, well, I don't know. So I said, well, how important can it be for your process when you don't know what it actually is? So therefore, they allow us as experts to come in and understand what the steam condition is so that we can actually make the mechanical correctness to improve those areas, particularly dryness and non-condensables. Those are the two big factors that will affect your process and obviously your plant equipment as well. All you need to do is just to have those two little or the three connections into your, if that was representing a bend going to your process, we'll ask you to put little 1/4-inch sockets or welded socket ins, and we come in with our equipment, with the various equipment that we have invested in, and we come and do your test. And then we'll give you a certification with our certified, qualified steam quality test engineers, because they have gone through a well-trained City and Guilds certification to make sure that they are safe to actually produce these certificates to give you the right certification for your dryness and your conditions of your steam, and they can do that for you. So just ask us and we're more than happy to assist you with that. a good benchmark to have to understand where your steam is. Now, we can also look at something. If you have some concerns currently, and you need to understand where you are within your process, I call this a Bible. What this actually does is we do an audit from your boiler house right through to your end process. There's about a 90 checkpoint that we actually do. And this checkpoint we actually put into a folder for you, a confidential report, which we then hand over and present to you guys and to you as industries. We'll tell you that these are the risks, and we normally assign the risks between 1 and 5, 1 being a low risk, 5 being a high risk. And with these risks, we either assign to eliminate it or to minimize it. And we'll give you the solutions. Now, this is a great tool to have, a great start off if you don't know where you are within your system. Now, that can be used at a quality measure, HACCP quality measure controls. And that can be saying that you are doing something and you are looking at making sure that whatever you're producing is safe for human consumption. Now, this report is actually fantastic. A lot of people are taking hold of this because they want to know where the plant actually is. Now, sadly, there has been some situations, and I always like to be honest with everybody out there. We as Sarco, we actually have the obligation. We have the duty to make sure that we provide the industries with the best solutions out there. Now, if you had to come to us, we will give you the guidance. We will not say do this or do that. What we will do is give you the best recommendation used for your best practice to make sure that you run the system as safe as possible to ensure that you have no contamination. There has been reputational damages. I don't want to mention who they are, but there has been. And there has been a lot of waste recalls, a lot of product. There was an industry not so long ago where they had smells coming from into the milk, and they dumped thousands and thousands of liters because obviously they didn't know where the contamination was coming from. Sadly, it was coming from the actual steam. So, they contact us as specialists, and we had to give them the guidance. We did the HACCP, we showed them where the risks are, and we said, this is the way, and this is a solution that you can actually eliminate it. And obviously they took our guidance and they went the clean steam route. There we are. Johan, I've handed over to you. If there's hopefully there's any questions, we can take it from there. Thank you all for listening. Hopefully that was interesting. Hopefully there was a awareness and some good guidances. And we are here to support you wherever you need us. Thank you, Johan.
Hi, thank you, Francisco. There has been 2 questions. One of them you've answered. What audit can we do to help with steam quality? I think you've answered that question. To add to that, they can make arrangements with Spirex, the local office, to assist with that. Then there's another question, very interesting question. It says here, is boiler chemicals not food safe?
Very, very good question. Okay, first of all, if you are running an industry such as food and beverage, then you are compelled to actually use food safe. Okay, but the interesting factor around food safe chemicals, they say, FDA do say, you can use food safe chemicals within the boilers, but you're not supposed to exceed the actual limitations. And they normally the limitations are milligrams. So limitations are milligrams of carryover that you can exceed within the actual process. But even that, it is very difficult to control. So they actually putting the ownership on you to make sure that you don't exceed those limitations. Now, how do you check that? Well, it's very difficult to do so. So therefore, the people or the industries out there, they want to make sure that they don't exceed that limitation. Then you go for clean steam because you know it's got no chemicals. Hopefully that answers that.
Yeah, I think that answers the question, and it also adds to the control that you need to have on your boiler system.
Absolutely.
it is very pertinent that these chemicals needs to be watched very carefully on your boiler system, and taking readings from these chemicals during your boiler's daily operation. I can add to that, Francisco, is only a reading in one specific moment in time. So as the boiler draws more or less steam, obviously the conditions would change. So understanding that if you do take a sample, it's only a sample in one moment in time.
Yeah, it's a good point you mentioned that. I'll always like to emphasize as well that as you well know, and as us as engineers and people out in industry, we understand this. When you talk about chemical dosing, when you are dosing for, let's example, your process is actually doing 500 kilograms an hour, then suddenly it changes to 2,000 kilograms an hour. Now, when you are dosing, you're either going to dose for 500 kilograms an hour, or you're going to dose for 2,000 kilograms. Now, if you are using 2,000 kilograms an hour, surely your dosing is going to be more than that of 500 kilograms an hour. So you see the inconsistency that there is over there. It's very difficult to get a happy media in terms of make sure that your dosing is always consistent for that loading that you are. And we know that our loading within our steam distribution system changes up and down depending on the process demand. If it was consistent, then you wouldn't worry, because then you have one dosing system, one dosing all the time continuously. But because there's so many variations and so many variables, that does change, and that's what adds to, as you were saying, at that particular time when you take it, it could be different every second.
Yes, there's another good question. It says, how often should we perform steam quality tests?
That's a very good question. You were saying now, and I was saying as well, steam changes every second. Now, when we talk about steam quality test, remember there's two things about steam quality. There's the purity side and there's the quality. Now, when we talk about quality, that's talking about the non-condensable, superheat, and dryness. Okay, that's the quality. The purity is the other one that is the variable that changes. When you talk about purity, it's the chemical context, is all the contaminants that the steam carries. That's the purity side, which does really affect your process. Smell and taste. How often do we go and take a sample of the condensate and drink that to make sure it's safe for the process? And when you say that to a lot of people, would you take your condensate and taste it to make sure that it tastes okay? A lot of people say, no, we won't drink your condensate, but yet it's actually condensing into your process. So if you don't want to drink it, then you should be adding a process as well. So it's very difficult to have that. To say you need to have, there isn't any measurements today that can use or can have inline checking the purity. Okay, there are systems today that we are developing that we can actually put inline that measures your dryness every second, because we know the dryness, if you've got excess wet steam, then you obviously got excess carryover. So there are systems that we can put, and we are systems that we are developing. And the system we are developing, hopefully it'll come out soon, it actually measures the steam dryness every second. It just shows you we need to understand and logically make sense that if we want to make sure that the steam is correct every second, then we need to understand what is the management and what makes up the actual water within the boiler. And that's the only way to do that is clean steam, because we know that the steam or the water entering the boiler is consistent at all times.
Yes, that there's another question following on your last remark that adds to that, Francisco. It says, how often should you remove condensate water from the system to put in new clean water to the system?
Well, that's a good question, because you don't know when the contaminants can occur. You don't know when the what contaminants the actual condensate carry. So again, if you want recommendation for us to give you that peace of mind And sadly, in respect to HACCP, the only way we can actually give the guidance and give the guarantees, because in the court of law, if we give you a wrong advice, then we are responsible for that solution that we provide you. So therefore, the only peace of mind that we or anybody can give you as an industry out there to make sure that your steam is consistent at every second is clean steam. We've gone through years and years of development to try to understand how we can eliminate those contaminants, those issues that are causing process safety into products and things like that. And we've developed a solution now that can actually eliminate that from happening, and that's where we can give you the guarantee. So we can put measures in to minimize it, but we can't give you that guarantee. The only guarantee that we can give you as a company is actually clean steam, because we know it's consistent.
Yeah, and also, Francisco, removing condensate water is not necessarily continuously needed, but you can, like you said in your presentation, there are monitoring systems that can be applied to the return of condensate that will dump whatever condensate is contaminated at that specific moment immediately. And it also allows you to go fault find in the plant to understand where that contamination is coming from. And that
Absolutely.
also obviously protects your boiler.
Absolutely, yeah, that's just a measure we can put into place, as you well said, yeah.
Then there's another question. It says, what impact on clean steam generator if plant steam is not dry?
Well, it's a good point, and I'm glad you've asked that question. Whoever asked that question, because they've taken note around my first slide, where we talk about making sure that we get the mechanical correctness of the plant steam to make sure that the equipment downstream gets the best efficiency. So obviously, if your steam condition is not correct to the actual generator, then you're going to affect the performance of the generator. So it's a good point. I'm glad that person's taken note of the first slide I put in there. It's just as important, your plant steam, as what it is on your process side. Well done for that question.
Okay, Francisco, it seems like we've covered all the questions as such. If there's any other questions from the attendees, please feel free to put them to us. If we get them and we haven't addressed them immediately in this situation and this webinar, we will see them afterwards and come back to you and make contact with you to answer them.
Brilliant.
Francisco, I would really like to thank you for your time and contribution today. With your reputation in the steam industry, concerning all your experience in the food and bev and what steam quality has been shown to get the performance of the industry better, where you've worked at Coca-Cola and all other food and bev factories that you've been involved with, improving them and helping them, making their process better. Again, thank you very much. It was a pleasure listening to you today.
Thank you very much. And as one of your candidates actually said, a good point is to start with a HACCP audit. So if they are interested, to contact yourselves, and as you know, I'll be visiting South Africa, for soon, and we can maybe arrange that. We've got, I think it's 4 or 5 HACCP audits in South Africa in a week or two. So it just shows you that a lot of people are taking interest in understanding where the risks lies within their process. So just contact us and we'll do whatever's necessary to apply those HACCP audits. Thank you all.
Yeah, thank you very much. And thank you, Debbie, for helping us controlling this today. Yeah, have a good day to everyone.
Thank you all.